Okay, so in this video we are going to sketch the graph of a trig function, and our function here, cosine of 2 times the quantity theta minus pi over 2 over the interval 0 to 2 pi. First, let me just show you real quick. I went on Wolfram and graphed this. If you haven't heard of Wolfram Alpha, it's a website for, you can do all kinds of things. www.wolframalpha.com. Very useful. You can graph all kinds of functions. You can graph in 3D. You can solve integrals, find derivatives, do lots of things. So check it out. It's worth your time. But just looking at this graph, you can see it has an amplitude of 1. It looks like the period is every pi, approximately 3.14159. And traditionally cosine starts at 1 and would, do its thing like that. But it's starting at -1, so obviously you can tell there's a phase shift, but that's the reason it's not starting up here at 1 like cosine normally would. Okay, so let's see how we would graph this. First, we can simplify this argument here. Anytime you can have y equals something, f of x equals something. That's the same thing, same notation. These two things are interchangeable when you're graphing, just so you know that. So y is equal to cosine. We can just distribute this 2 through following normal algebra. That would give you 2 theta minus pi. Okay, so we need to work with this, and if you remember from trig or pre-calc, anytime you have a coefficient in front of your variable, or our variable is being theta, and the coefficient in this case is 2, that's going to have an effect on your period. So your period, if the coefficient is just 1, your period is going to always be 2 pi. Since we have this coefficient, let's call this coefficient c. The rule is your period then is going to be 2 pi divided by that coefficient c, which in this case is 2 pi over 2, which simplifies down to just pi. So we know that this trig function here is going to repeat at an interval of every pi. It's going to begin its repetition. Okay, now this piece here, that's a phase shift. And the way you find out a phase shift is, it's a combination of what we have here. In this case it's negative pi, and then also this coefficient here. To find out your phase shift equals the opposite of whatever this is. So that would be negative pi, and then you divide it by that coefficient over 2. So our phase shift equals just positive pi over 2. Okay, so that's all the information we need to start graphing. So let's label this graph here. We're going from 1 to -1, and then let's set up the x-axis. There. This would be pi over 2 pi 3/2 pi and 2 pi, and let's just throw on -pi over 2 here, and here's our origin. Okay, so now traditionally I'm going to graph this in a few steps so you can see how this works. The regular cosine function starts at 1 and its period is 2 pi, so it would start here, come down like this, come back up, and then right at 2 pi it picks up where it left off, or leaves off where it picked up, however you want to look at it. If we incorporate this period here, our graph is going to look, instead of repeating every 2 pi, it's going to repeat every pi. So it's going to come down like this, come up, that's not good, come down, swoop, come up, and sloppy, but you can see it's the same thing, just repeats every pi. So now, alright, I'll just finish this. There we go. Now it's been shifted 2 pi, so I'll do this one in green. So to take into account this phase shift of 2 pi, you're just shifting this graph over in the positive direction pi over 2. Let me get a darker color. It's not showing up very well. Pi over 2. So, I mean, we're not showing it, but you know that this graph here comes down, and this is confusing. It would come down like this. So just imagine if you took this pink graph here and moved it over 2 pi, or pi over 2 rather. It would start here at -1 and do the same exact thing. So we come up here like that, come down, come up there, and then end right down here. So I know there's a lot of stuff going on here. Hopefully you can follow this, but this last graph here I drew, that's this right here. And if you look at the graph from Wolfram, it should be the same. You can see we start down here at -1, we end at -1, it repeats twice over the interval 0 to 2 pi, and that's exactly what this graph does. Starts at -1, one repetition, second repetition, ends down at 2 pi. So hopefully that helps with graphing trig functions. And all these phase shifts and how to find out your period, that applies to sine or cosine. And the only other thing is the amplitude. You know, if this had a 2 here, then it would have gone to 2 and -2. Or if it, you know, had any number, that number just indicates amplitude. Okay, hope that helped.